Next up, a little more systems. Let's do a couple more of these and then we'll call it a day on systems and move on to the next topic. This one, not too bad on the left here. I'm going to multiply the bottom equation by 2. So I've got 4x minus y equals 20 on top. And on the bottom, if I multiply the entire equation by 2, I'm just going to get minus 4x minus 4y equals, I'm multiplying by 2, so 20. I'm going to combine them, linear combination, add them together. So 4x minus 4x, they get added together to eliminate the x's, and I get minus 5y equals, 20 plus 20 is 40, so I've got y equals minus 8. All right. And then I'm going to sub that back into one of the original equations. I'm going to choose, let's take a look. I'm going to use the bottom one. I'm just going to use the bottom one because it's got 2's in it instead of 4's. I don't know, it might be harder, who knows. But let's just go with that choice. And so we got minus 2x. It's minus 2y. And y in this case is going to be negative 8. That equals 10. Okay, so minus 2x plus 16 equals 10. We're going to take away 16 from both sides. So minus 2x is going to be equal to negative 6. That means that if we divide by negative 2, x is equal to 3. All right, and there's our solution for that system right there. So that's our first one out of the gate. Now for our last and final elimination, substitution, systems of equations problem. I'm looking over here now, and I'm seeing 6 and 7, let's not make that too hard. I like the 2 and the 6 because I can just multiply the top equation by negative 3. So I'm going to have 6x plus 6y equals 0 as one equation, and then underneath I'm going to come down here and multiply everything by negative 3. So I'm going to have 21x, I'm going to have minus 6y, 0 times negative 3, still 0. So this one is looking kind of nice at the moment. Let's see what happens here. I just realized I did not multiply 18 times 3. Duh. Let's fix that. Negative 3 times 18, that is 54, I believe, but it doesn't hurt to check it with a calculator. 54. Okay, and it's negative because I multiplied by negative 3. Caught myself right there. All right, let's see what we got here. 6 plus 21, that would be 27x. 6y minus 6y is going to be goodbye, equals negative 54. Now, if you take a calculator, 54 divided by 27 is 2. So 27 times negative 2 would give me negative 54. That's what I'm going to need to do there. And then I'm going to need to go back and sub and figure out what goes where. I'm going to go with the 6x and the 6y. So 6 times negative 2 plus 6y equals 0. Or negative 12 plus 6y equals 0. Well, solve away, but really negative 12 plus 12 equals 0. So that means that y has to be equal to 2. It's the only way that works. That would give me negative 12 plus 12 equals 0. So now I've got my solution, and that's the last of our substitution evaluation systems problems. Let's charge on ahead to a little bit of like terms. This is, take a deep breath, it's simplifying, not solving. There's no x equals here. It doesn't happen. There's no equal sign. So it's just like terms. So 2x minus 2x gets eliminated. Minus 4 plus 6, that's going to give me a minus 2. And over here I've got this x right here. So I've got x minus 2. So I'm looking for like terms. I'm on a little hunt, if you will, a little Friday afternoon excursion before spring break for like terms. Okay, over here I've got a minus 3x and a minus 7x, so that's going to give me a minus 10x. And then 13 minus 12 is my plus 1. Left, right, minus 6x plus 10x, that's going to give me 4x. And then 3 minus 13, negative 10. Okay, so you notice these ones take a lot less. Let's go above the ones on the bottom here. Let's just get these done here. 2x squared minus x squared would give me x squared. And 6 plus 5 would give me 11. So I'm just combining like terms. Like terms, same variable, same exponent. I've got here minus 4x plus, so that's 3x squareds. Do I have any x's? Yeah, I got plus 3 minus 4, so that's minus 1x or minus x. And then I've got a minus 3 on there at the end. So I'm just checking real quick before I go any further. That one looks good. Okay, moving right along here. Last piece of the puzzle for today is these guys. We just did these in class today, actually. This is a lot of lesson 5, so a lot of lesson 5 work here. Let's go ahead and distribute. 3 times x is 3x. 3 times 2 is 6. We were trying to do this without area models, without too much work, just more mental now that we're in Math 2. We're going mental in Math 2, folks. X times 5 is going to be 5x. And x times x would give me x squared. Okay, this one right here, minus 3x times minus 3x would give me minus 9x squared. And minus 3x times 4 would give me minus 3 times 4 is 12. And that is an x with it. Okay, we're going to come on down a little below that one. Next one. Ooh, good stuff. This one I'm going to hang on to for a moment. I'm going to come back to that one because that's a little bigger than we've done so far. So I'm going to pick off the low-hanging fruit here. Get the easy stuff done. So let's go on down to the bottom right down here. I'm looking right here at the moment. Bottom right. Bottom left, sorry. That's x squared because that's first terms. The back end, minus 9 times 4. Minus 4 is plus 36. And in the middle, you've got that that minus 4x and minus 9x. You got minus 13x. All right, so we're good there. Same thing here, x squared minus 14. And in the middle, minus 7x plus 2x would give us minus 5x. Like I said, we're showing a little bit less work now. If you're not sure, you might want to go back and check Khan Academy for multiplying binomials. X plus 5x minus 5, you might remember it as there's the first term, there's the last term, and there is no middle term. I know that's rare, but you're going to get minus 5x on the inside and plus 5x on the outside. Excuse me, plus and minus 5x. They cancel each other out. That's called a difference of squares. And our last one up here, x squared plus 81. And in the middle, the pattern for today was times x times 9. So 9x and then double it. So plus 18x. And that is a perfect square trinomial. All right. Now back up to the dreaded one on the top right. This guy requires a little bit of what we would call modeling. Draw the box. It's easier. You got a 3x on the left and a plus 4. That's the length of the box. The width of the box would be a minus 2x plus 1. So the area model is going to help you here. It's going to help you keep it organized. So 3x times minus 2x would be minus 6x squared. 1 times 3x is 3x. 1 times 4 is 4. So I'm just multiplying the length and the width of each section of the box. It's still FOIL, but I like the box on this one because there's so many numbers, it's a bigger problem. And then 4 times minus 2x is minus 8x. I come out of the box, I've got minus 6x squared. These two guys right here combine because they're like terms. So 3x minus 8x is minus 5x. And then a plus 4 on the end. And that is the area model method. So we use the area models when things get a little big and hairy. All right, rewind if you need to go a little slower and check that out again, but it's somewhat of a review. We've done that in class. A lot of that was lesson 5. All right, and we're going to call it right there at 9 minutes and 33 seconds. Enjoy your spring break, folks. I'm going to stop right there.